we're taking a look at moving straight ahead, checkup number 1. All right, so we have table number 1. We're being asked if table 1, 2, or 3 are linear relationships. And we know a linear relationship has a constant rate of change. So for every one of the independent variable, there'll be a constant change for the dependent variable. So let's take a look at this one. We have a change of 1, change of 1, change of 1, change of 1. And this it's making it pretty easy on us that we're counting by ones on the x value, or the independent variable. And right away, I can tell that this is just not going to be okay. This is not linear. All right. So again, we have a change of 1 in the independent variable. Here we have a change of 10. So this is linear. For table 3, this is a change of 1, a change of 1, a change of 1, change of 1. This is a change of -2. It's going down by 2 every time. This is also linear because we have a constant rate of change. That's an A if you play along at home. So write an equation for this. So table number 2 ends up being a proportional relationship because it goes through 0, 0, which makes life really, really easy. What we're doing here is we're multiplying 1 by 10 every time. 2 by 10. Multiplying 3 by 10. So really, we're just taking the, to get the money, M for money, we're just saying 10 times the distance. For table 3, well, this is a little bit trickier because we do not have a proportional relationship. It's still linear, it's just not proportional. It doesn't go through 0, 0. So remember how that starting value always ended up in the table, or in the graph, and the equation. So we always had to add that 10, and then the rate of change is what we multiplied the independent variable by. So if we have -2 times the days, that should equal the money. Now, let's double check. Let's make sure this works. That's always a good idea. So when the days are 3, we should get $4. So -2 times 3, because 3 is the number of days, plus 10 is equal to money. That's -6 plus 10 is equal to money. That's equal, so the money is equal to 4. Oh, that's what we got here. So we have an equation that works. All right. So question C. Which represents a proportional relationship? Well, that's table 2. And that's because the line goes through 0, 0. All right. For each graph below represents a linear relationship between time and distance. For each graph, what is the rate of change? So we're going over 2, we're going up 2. Oh, and also, when time is 1 second, we're at, oh geez, but wait a second, that's 5 seconds. So we didn't go up by 2, we went up by 10, right? From 0 to 10 is a difference of 10. So we have our rise, we have our run, and so the rate of change is going to be our rise over our run. You didn't have to write that, by the way. So that's 10 over 5, which is equal to 2. Here, well, we have a change of 1, and that got us 20. And that happened again here, didn't it? 1 over 20, yeah. All right, finally, this one is not proportional. So I'm using this point here, and so we're going 1 over, and each line, that's 15, each line's worth 5, so we've gone up 10. So this one has a rate of change of 10. right. Jason is participating in a walkathon. He writes the equation M money is equal to 2 times his distance plus $50. Represent the amount of money he collects from each sponsor for walking. $50. I should be trying to raise money for the school that way. For walking D kilometers. What number represents the rate of change? Well, the rate of change is what we get for every time we do, in this case, walking 1 kilometer. So every time we walk 1 kilometer, we get $2 more. And that represents the rate of change. Sierra is keeping track of the amount of money in her lunch account each week. She writes the equation A is equal to -6W plus 40. What number represents the rate of change? Well, same thing. So what are we multiplying every time? -6. All right. Mark opens a bank account with $20. He plans to put $50 away each week. Okay, so we've always got to start at 0. All right, and we're starting with $20 because he said that he's starting with $20. We're adding $5 per week. Use the grid to make a graph for the table. So we have time, we have money. All right, so our time is 0. I'm going to count by ones, but I'm only going to label every other. And we need to go from, we really should start at 0. And then we should get up to 70. So I think I can count by 5. So 10, 20, 30, 40, 50, 60. I got to count by tens. So 10, 20, 30, 40, 50, 60, 70, 80. Now I would rather count by 5s, but then I go off the grid. I don't want that. And this is, we're going to label this graph money saved over time. All right. So 0, 20. And I don't have to put every dot in here, right? 2 and 30. Let me just put a slash there. Let's go with 8 and 60. 10 and 70. And then I can connect the dots. And look, it makes a straight line. Don't forget that little arrow at the end, make sure it goes on forever. Write an equation to represent the total amount of money Mark has in his account. Well, we know the starting value is going to be a plus, right? So we are plus 20. And we'll go with money. And what are we increasing by? Well, we're increasing by 5 every time. So 5 times, I'm going to use W for weeks. And that equals the amount of money. In which week will Mark have a total of $60? Well, there are a couple ways we can do this. One way we can just say in week 8. Or we can go in a different color here. Week 8. Or, the most fun way of all, we can say 5W plus 20 is equal to 60. Well, minus 20 minus 20. 5W is equal to 40 divided by 5, divided by 5, and I get W is equal to 8. Now, if you weren't able to follow what I did here, don't worry. This is something that is taught in Investigation 3 in this book. So this is a little bit advanced of where we are. If you use the table or the graph, that's fine too. Explaining your reasoning would simply be, well, this is an explanation right here. It's a mathematical explanation. Or you could have this on your graph, this little dots, and show us how we got it in the graph. And say how you got it in the table, graph. Or clearly you can just say how you looked in the table. All right, so that is everything. Make sure you do any corrections that you need to do in pen, and I would like you to submit your work to the discussion post. And if you got them all right, let me know. If you missed one or two, that's okay. Just let me know which questions you missed. No big deal. All right, have a great weekend. Oh, don't forget to do your manga. Bye.